Um, equation the curve given, equation of the curve, which is a circle, x square plus y square equal to a square. Now this is a very simple circle because this is center is at the origin and radius is a unit. Now this is the circle which you got. This is a circle equation, which is x square plus y square equal to a square. So this point we can say as a comma 0. This is 0 comma a. Now we are finding, we have said that there is a line which is touching the circle and it is a tangent. So equation of the line touching this circle, equation of the line touching the circle in bracket tangent is y equal to x sin alpha plus a sec alpha. We mark this as equation. Now since it is a tangent to the circle, that means at the point of contact this will act like a tangent. X1 comma y1, not act like a tangent, it is a tangent. This line is a tangent. So if we find the equation of tangent here, that one and this one should be identical, and then we can compare and get the result. So to find the equation of tangent at the point P, at first we find the slope of the tangent. Now before that we have to take the point of contact. So write down point of contact P x1 y1, which will satisfy the equation, which will satisfy the of circle. So that implies x1 square plus y1 square equal to a square. So to get the tangent, we need the slope of the tangent. So to get the slope of the tangent equal to slope of the curve at x1 y1 equal to ddx of y at x1 y1. So on differentiating we get this one as minus x by y as ddx of y. So here it will be minus x1 by y1. Now equation of tangent. Y minus y1 equal to slope into x minus x1. Which one further simplification? Y1 minus y1 square equal to minus x1 plus x1 square. Now from this we get x1 plus y1 equal to x1 square plus y1 square, which is equal to a square by equation 2. So this is the equation of tangent x1 plus y1 equal to a square. Now this is also in accordance with the shortcut, that is x can be treated as x1, y square can be treated as y1 equal to a square. Now this equation which I have represented by 3 and equation 1 should be identical. Now from equation 1 and 3 should be identical. So on comparing the coefficients, we get x1 by minus sine alpha equal to y1 by 1 equal to a square by a sec alpha. Now from this we simplify and we get x1 equal to minus a sine alpha cos alpha and y1 we get as a cos alpha. Now x1 and y1 will satisfy equation 2. So we get minus a sine alpha cos alpha whole square plus a cos alpha whole square equal to a square. Now from both the factor we can take a square cos square alpha common and we get sine square alpha plus 1 equal to a square. This gives us cos square alpha into sine square alpha plus cos square alpha equal to 1. And from this we get cos square alpha sine square alpha equal to 1 minus cos square alpha. Now 1 minus cos square alpha will give us sine square alpha. So from these two terms we can take sine square alpha common and we get cos square alpha minus 1 equal to 0. Now from this either sine square alpha equal to 0 or cos square alpha equal to 1. Both the conditions are giving rise to the same situation that cos square alpha equal to 1. Because when sine square alpha equal to 0, 1 minus sine square alpha will give us cos square alpha. So that gives us cos square alpha equal to 1. So this is the required condition. Alternate method. Now this is a conceptual method, very nice method and simple method. Here the equation of circle is given. Equation of circle x square plus y square equal to a square. Now this is y, this is x, this is x prime, this is y prime, and this is origin. Now this is a circle whose center is the origin, radius is a. Now if any line touches this circle, then it is definitely the tangent. It is definitely a tangent. This is a point P, x1, y1. Now we don't need, in this method, we don't need the point of contact. Why? Because we will not differentiate on. Here, does the equation of line is what? Equation of line. Tangent to the circle. Y equal to x sine alpha plus a sec alpha. Now, we represent this by equation 1. Since it's a tangent, distance of the origin from the line should be equal to radius. Write down. Distance of origin or center of the circle. Distance of origin in bracket center of the circle from the line tangent is equal to radius. Now, what is the radius here? Radius is a unit because a square plus a square equal to a square. So, under the given condition, we can say a equal to mod of 0 plus a sec alpha minus 0 by root over of sine square alpha plus 1. Distance formula. From that we got this. Now this means what? This means that sec mod of sec alpha by sine square alpha plus 1 to the power of half equal to 1. Now from this sec square alpha equal to 1 plus sine square alpha. We have taken sine square alpha, which is 1 by cos square alpha. Now, if we simplify this, what we get? 1 equal to cos square alpha plus sine square alpha cos square alpha. Now, 1 minus cos square alpha equal to sine square alpha cos square alpha. Now, sine square alpha into 1 minus cos square alpha. Now, this implies sine square alpha equal to 0 or cos square alpha equal to 1. Now, when sine square alpha equal to 0, that means cos square alpha equal to 1. So, ultimately, from both of them, we get this condition. It is given the line x cos alpha plus y sin alpha equal to p is a tangent to the parabola y square equal to 4x. Now we take the equation of the parabola as equation 1. Now since it is a tangent, so at first we draw the parabola. Y origin x prime y prime. Now this is a parabola, so y square equal to 4ax. Now here, if this line is a tangent, we can draw it in this way. We can just represent this in this way. Now, if it is a tangent, this is the point of contact. Now, that equation of tangent at this point, and this one should be identical, this line should be identical. So, for finding the equation of tangent, you need the point of contact as well as the slope. So, write down P x1, y1 be the point of contact. So, it must satisfy the equation. So we get what? Y1 square equal to 4ax1. Now after this we find the slope of the tangent at this point. So slope of the tangent equal to slope of the curve at P x1 comma y1 equal to ddx of y at x1 comma y1. Now that gives us 2a by y1. And from this we find the equation of the tangent. Equation of tangent y minus y1 equal to 2a by y1 into x minus x1. Which on further simplification? Y1 minus y1 squared equal to 2ax minus 2ax1. Now using equation 2, we can write using equation 2, we get y1 equal to 2x plus x1, which we mark as equation 3, which is identical to x cos alpha plus y sin alpha equal to 2. Now, on comparing the coefficients, we get 2a by cos alpha equal to minus y1 by sin alpha equal to minus 2a x1 by b. This implies x1 equal to minus p by cos alpha, y1 equal to minus 2a sin alpha by cos alpha. Now, since x1, y1 will satisfy the equation because this is the point of contact, so we get that 4a square sine square alpha by cos square alpha equal to 4a into minus p cos alpha. And this gives us a sine square alpha equal to minus p cos alpha. That is a sine square alpha plus p cos alpha equal to 0, which is the required condition. Here it is given that the line x cos alpha plus y sin alpha equal to p tangent to the curve x square by a square plus y square by b square equal to 1. That is the ellipse. So here at the beginning we take an ellipse. We have this one y, this is x, origin, x prime, y prime. Now this is an ellipse whose vertex is at the point a comma 0. Now the line is touching the ellipse. So this is definitely a tangent. This is a point P at the point x1, y1. So the line is a tangent to the ellipse. So that means we need to take we find a tangent at this point, at the point Px1, y1. That line and this line should be identical. So point P x1, comma y1, point of contact. Point of contact. So it must satisfy the equation. It must satisfy the equation of ellipse. So what we get? X1 by a square, y1 square by b square equal to 1. And we mark it as equation 2. Now to find the tangent equation, we need the slope of the tangent at the slope of the tangent at this point, and slope of the tangent at this point equal to slope of the curve at this point. So slope of the tangent at Px1, y1 equal to slope of the curve at P x1, y1. So ddx of y at x1, y1. Now on differentiating this equation, we get minus b square x1 by a square y1. And from that we can find the equation of tangent. And therefore, equation of tangent y minus y1 equal to m into x minus x1. Now, if we simplify it, that is, we take y on the left hand side, y1 on the left hand side, equal to minus x1 by a square minus plus by a square. So we get here x1 by a square plus y1 by b square equal to x1 square by a square plus y1 square by b square, since the point of contact by equation 2. So ultimately we get the equation of tangent as x1 by a square plus y1 by b square equals to 1. Now this equation and the equation of the tangent given should be identical. That is 1 and 3 should be identical. So equation 1 and 3 should be identical. Now that means what? We can write here cos alpha by x1 by a square equal to sin alpha by y1 by b square equals to p by 1. Now from this we can find x1, which is a square cos alpha by p, y1 b square sin alpha by p. This must satisfy, this should satisfy equation 2. Write down will satisfy equation 2. So we write a square cos square alpha by p square plus p square sin square alpha by p square equal to 1. And this implies a square cos square alpha plus b square sine square alpha equal to b square. Equation of curve x square by a square minus y square by b square equal to 1. Now, line x cos alpha plus y sin alpha equal to p is a tangent to the hyperbola. Which we mark as equation 2. Now this is x origin, x prime, y prime. Similarly, the other points. Now, the line be this one, which is tangent. Now, if this is the line, this is the point P x1, y1. Now, if we find the equation of the tangent at this point, that tangent and this one should be identical. So, we say that P x1, y1 be the point of contact. Be the point of contact. So, x1 square by a square minus y1 square by b square equal to 1. Now we mark this as by equation 3. Now, on differentiating equation 1, we get the slope at the point P. So on differentiating equation x square by a square minus y square b square equal to 1, we get ddx of y equal to b square x by a square y. Therefore, slope of tangent equal to b square x1 by a square y. This implies equation of tangent line y minus y1 equal to b square x1 by a square y1 into x minus x1. On further simplification, we get equal to x1 by a square minus x1 square by a square. Now x1 by a square minus y1 by b square equal to x1 square by a square minus y1 square by b square equal to 1 by equation. Therefore, equation of tangent which we are getting x1 by a square minus y1 by b square equal to 1. That is the equation of tangent. Now we mark this as equation 4. Now equation 1 and 4 must be identical. Equation 1 and 4 must be identical. So that is x1 by a square cos alpha equal to y1 by b square sin alpha minus equal to 1 by p. So x1 equal to a square cos alpha by p and y1 equal to minus b square sin alpha by p, which will satisfy equation 3. So a square cos square alpha by p square minus b square sin square alpha by p square equal to 1. So a square cos square alpha minus b square sin square alpha equal to p square, which is the required condition. Equation of the curve. Equation of the curve ax whole to the power of n plus by whole to the power of n equal to 1. P x1 y1 be the point of contact. So it must satisfy equation 1. This implies ax1 whole to the power of n by1 whole to the power of n equal to 1. Mark it 2. Now to get the equation of tangent, we need the point of contact. We have got that. Now on differentiating, we have to find the equation of the slope. I mean, we have to find the slope. So on differentiating, equation 1 with respect to x, so what we have got, ddx of y equal to minus x to the power of n minus 1 a to the power of n by y to the power of n minus 1 b to the power of ddx of y at x1 y1 equal to minus x1 to the power of n minus 1 a to the power of n by y1 to the power of n minus 1 b to the power of n. Equation of tangent is y minus y1 equal to slope x1 to the power of n minus 1 a to the power of n into x minus x1. So we cross multiply n minus 1 into b to the power of n plus x1 to the power of n minus 1 a to the power of n equal to a to the power of n x1 to the power of n plus y1 to the power of n b to the power of n. Now that is 1 as by equation 2. Now we have got the equation of tangent as y1 to the power of n minus 1 b to the power of n plus x1 to the power of n minus 1 a to the power of n equal to 1. So this is the equation of tangent which we have got. Now we mark this as equation 3. Equation 3 and Lx plus my equal to 1 should be identical. Now this implies x1 to the power of n minus 1 a to the power of n by L equal to y1 to the power of n minus 1 p to the power of n by n equal to 1 by 1. Now from this we can say that x1 to the power of n minus 1 into a to the power of n minus 1 into a equal to L. This implies ax1 whole to the power of n minus 1 equal to L by a. Now similarly by1 to the power of n minus 1 equal to m by b. Now as per the equation 2, from equation 2 on substituting L by a to the power of n by n minus 1 plus m by b to the power of n by n minus 1 equal to 1, who is the required condition. Here given equation of the curve, equation of the curve x to the power of n into y to the power of n equal to e to the power of n plus n, which we mark as equation 1. To find the tangent, we need a point of contact. So at first we consider point of contact. So point of contact we take as p, which is x1 comma y. And to find the equation of tangent, we need the slope of the curve at that point, at this point of contact. Now, since this is a point of contact, it must satisfy the equation. It must satisfy the equation of the curve. So, x1 to the power of n, y1 to the power of n equal to a to the power of m plus n must be true. Now, we need to find a slope to find the equation. So for that, we need to differentiate this curve because we want to find the slope of the tangent at that point. We know slope of the curve at p x1 comma y1 equal to slope of tangent Therefore, on differentiating equation 1. On differentiating equation 1, what we did, x to the power of m into n into y to the power of n minus 1 dx of y plus, here y to the power of n is differentiated, so n into y to the power of n minus 1 dx of y. X to the power of m is as it is. Now we keep y to the power of n as it is. M into x to the power of m minus 1 equal to 0. Now from these dx of y will get as minus m into y to the power of n x to the power of m minus 1 whole divided by n into x to the power of m into y to the power of n minus 1. Now we are finding this at the point of contact. We are finding slope at the point of contact. So x1 y1 into y1 to the power of n x1 to the power of m minus 1 x1 to the power of m into y1 to the power of n minus 1. So that is the slope of the curve at the point P x1 y1. Now once we have got the slope, we can find the equation of the curve, equation of the tangent. Now we can further simplify this one because you can see here it is x1 to the power of m by x. So here we'll get a x. And similarly this one also we can simplify. So what we get ultimately, it is minus m by n into y by x. That is the slope of the curve. Now we can say that equation of the tangent, equation of tangent is y minus y1 equal to slope. Here slope is m by n y1 by x1 into x minus x1. Now from this, if we simplify, it is n x1y minus n x1 y1 minus m x y1 plus m x1 y1. This one simplification should give us n x1 y plus m x y1 to m plus n into x1 y1. This is the question number 4. Now the line which is touching the curve is given as x cos alpha plus y sin alpha. Now that line and this line should be same, which is the tangent and that is touching the curve. So we can compare it here. That is x cos alpha plus y sin alpha. So we write here y sin alpha plus x cos alpha equal to p. Now this equation 4 and 5 must be identical. Equation 4 and 5 must be identical. So on comparing the coefficient, what we get, nx1 by sin alpha equal to m y1 by cos alpha equal to m plus n x1 y1 by p. Now from this we can find out the value of x1 and y1. So this on further simplification gives x1 equal to pm or mp into m plus n into cos alpha and y1 equal to pm by m plus n into sin alpha. Now from equation 3, we can say that x1, y1 will satisfy. From equation 3, we can conclude x1, y1 will satisfy x1 to the power of n into y to the power of n equal to a to the power of m plus n. Now if we substitute the values of x1 and y1, we get p to the power of m to the power of n by cos to the power of m alpha into n plus m whole to the power of n into p to the power of n into n to the power of n by sine to the power of n alpha into m plus n to the power of n, and that is a to the power of m plus n. Now, if we cross multiply this, we get the simplified form as e to the power of m plus n into m to the power of n into n to the power of n equal to a to the power of m plus n into m plus n to the power of m plus n into sine to the power of n alpha into cos to the power of m alpha. Okay. So this is the required